All right. Today is going to seem like a big shift from what we were doing yesterday, but it really is the same section because these formulas that you are getting today are all exponential equations, and that is what section 3.1 was, is about exponential equations. And so although it is not going to look a lot like what we did yesterday, that's why they're grouped together. Okay. Today it's going to look like you get 4 formulas. It is really a variation of just 2 formulas. You have to know how to use them, when to use them, where to use them, but you don't have to memorize them. These 2 formulas, which are going to be in our notes in just a second here, are going to be handed to you always. Anytime you are asked to use them, you just need to know which one and how on your calculator with the numbers, all of that. But don't spend any time memorizing. The first one is your compound interest formula. This one is used a lot for financial situations, but we are going to use a variation of this for just any old exponential growth or decay formula. And off to the side, I have what each of those letters represent. A is the amount at the end of the problem. A is your total, your ending. P stands for principal. Principal means how much you start with, the initial amount. R is your interest rate. On your interest rate, you will almost always be given an interest rate as a percent. You will always need to convert that to a decimal. For example, if they told us that our interest rate was 1.2% for the problem, we would use an interest rate of. Now, who knows how to move from a percent to a decimal? Yeah, is this what some of your heads were thinking to do? Okay, a lot of people give me the little two swoops to the left here. I'm dividing by 100 is what I'm doing because a percent is out of 100. So I'm dividing by 100, moving my decimal 2 spots. If we ever have an open spot, we fill that in with a 0. So that would be 0.012. N is the number of times your interest is compounded, figured out, per year. We're going to talk about a couple different words for that. They will never really come out and say N equals blah, blah, blah. They will tell that to you in a vocabulary word. N will only show up in financial questions. So if it is not financial, N will automatically equal 1. It's just the financial situations where they will compound an exponential situation more than 1 time a year. And then T represents the number of years, like if you were to leave your money in a savings account for 5 years, T would be the 5. Okay. One thing I do want to point out, N shows up 2 places in your function, and the thing I notice when people make a mistake, especially on this first problem, is that they don't change the N in both locations. Those are the same number, represents how many times our money is compounded per year, but it does show up there twice, same number. Okay. Any questions? We are going to know how to use this. We do not need to memorize. All right, anyone still need this page? This is just a page of vocab words. Now, if you read this vocab word and you would have immediately known what N value to pick because of that word, you probably don't need to write much down. But if there's a word that you didn't recognize, I would jot that in my notes. And it says this: how many times a year do you compound your interest for each of these words? Annually would translate to an N value of 1. Semi-annually, twice. You got it. Quarterly is just how it sounds. 4 times a year. Monthly, hopefully we know that there are 12 months in a year. Daily, do not overthink daily. 365, it's not a leap year, don't worry about that, okay? And then weekly, 52, thank you. Now, with that being said, yes, these are all possible words we could run across. You will most often see quarterly, monthly, or annually. Those are the ones that we will are by far used more than the rest. Okay? Questions on any of that? So as we go back to the equation we just saw on the last page, that number that, so if I decide they say monthly and n is 12, I will put a 12 both here in the denominator and there in the exponent.
You put a 0.12.
Nope, that is n. We change the rate to the decimal, not to the n value. Yep. Okay. The last thing before we actually get into a problem is just the whole rounding situation. We're going to run into a lot of ugly numbers here because it's all calculator stuff. First of all, first step, always follow the directions. So if your directions are specific, round to the nearest fill in the blank, okay, that's what you do. If they are not, first of all, for money should be enough direction to know to round to 2 decimal places because money is always 2 decimal places. Now, I've had this conversation multiple times over the years, which is why I put this up here. When dealing with money and a bank does not round your money. For example, if you had in your bank account or you were supposed to get interest that was like $12 and let's say $34.47, let's go 35. They would not round this up to 35 cents. They're not going to give you more than you have actually earned. Okay? They do what's called truncating, where they literally just cut it off after that number, and they would only give you the 34 cents. Right? They're saying you haven't earned a full another penny. So, yes, truncating exists in banking world. We are not going to get that detailed with this whole thing. Round numbers like you know how to round numbers. With that being said, let's talk about rounding numbers. You round. You round like you know how to round. Okay? So like this would be, banks truncate, we will not. We will not truncate the numbers. Yeah, we will not truncate a number. Banks would. Yes. I do want to talk about rounding though real quick. Remember that if we are rounding to 2 decimal places in money, that means this number right here is getting rounded. You only look at the number next to it. Yes? It is not a domino effect. It is not a domino effect. It is not a, well, the 7 rounds the 4 up to a 5, and then the 5 would round the 4 up to a, it does not work down the line like that. So it does not matter what follows, right? It is literally just the number in front of it and only, and that number will not change, no matter what this is over here, okay? So that's just a quick reminder on how to round numbers. 5 and up, we round that number up. 4 and below, it stays what it is, right? Okay, any questions on that part of it? All right, this is a get to know our calculator page. We're going to do the first one together. And then if you get that one correct, I want you to move on to the rest of the ones, and I will put the answers up here, and you're going to make sure you're getting those same numbers on your calculator. We're going to read through the situation up there. You don't need to write down the formula because you already have it. Let's go ahead and find the numbers in there that we're going to use. You invest $1,000 at an interest rate of 9% per year. You leave the money alone for 20 years. Find the amount in the account if the interest is compounded. I will tell you right now, I don't know if you have ever paid close attention to like how much you make percentage-wise on like a bank account. 9% would be astronomical. You're not going to find a savings account that's going to give you 9% interest a year, and if you do, put all your money there, okay? So that's why these numbers are going to seem kind of big here. But it says we put $1,000 in there. $1,000 is what variable over there? Principal, right? That is what we put in initially, $1,000. Principal, what you started with, okay? Now, obviously, it tells us the word right here, a rate of 9%, which means we're putting in an R value of 0.09, right? Always moving that decimal 2 spots. It currently starts behind the 9. It's a whole number. I move it 2 spots, so 0.09. And then we leave the money alone for 20 years. 20 is what variable? T, right? And then we move down to these words down here, and these are our N values. Find the amount of the account if the interest is compounded annually. And this goes back to that page that we were just looking at earlier. Annually would be an N value of 1. So putting all of those numbers in the correct places up there, it would look like 1,000 times 1 plus 0.0, get that in your calculator correctly, 0.09, divided by our N value of 1, raised to the N value of 1 times 20. Now, I will give you a little hint if you have a nicer calculator. If you type this in as a fraction, it's a lot easier to go back and do this 4 more times without having to retype the whole thing. So grab your calculator, type that in, round to 2 decimal places because we're talking money, and then you're going to check your answer with what I have on the board here. And then if yours does not match, you're going to call me over and have me look at what you have typed in. First one should be $5,604.41. If that is not what you have on your calculator after typing in that first one, have me come over. If that is what you have on your calculator on the first one, go ahead and move on to the other 4 that are up there. Short a parentheses here. I added 1 more parentheses at the end here. So you need to double parentheses that end. Anyone else not getting that number? Okay, after you do that first one and yours matched, which is what everyone is in here right now, right? Here's how we're going to speed this up. Something you may or may not know about your calculator. No. Yes, you can. You do not have to retype it in every single time. If you hit second enter, it will take what you typed on that line and put it down there where you can just arrow back over and change your end value. Second enter, and if it doesn't, then you're going to have to retype. I'm going to put the rest of the answers up there. And again, sometimes translating to the next ones, we are not typing it in correctly. So make sure, again, as we go, that you are matching all of my answers. They are exponential equations. That's about it. There is no weekly. Remember, if you are not getting those numbers up there, did you change both places that n should be in your equation? Commonly forgotten is that second place up here in the exponent. If you are not getting the number that I have up there, that's what I would check. If you still aren't getting the number that I have up there, please let me see your calculator. Okay, so again, half of this is knowing where to put the numbers, but also typing it into our calculator the right way. This was your check. Any questions? Now, there is one more way of compounding that is not a word we see up there, and that changes us to a whole new formula, and that is when we see the word continuous, or continuously is actually what we want to look for, continuously. So if they tell us that our interest is compounded continuously, we move to this new formula, which is frequently referred to as PERT. Can you see the word PERT back here? Okay. Usually they refer to it as this, and again, that's our tie to yesterday. That is an exponential equation. It's got a base of e. The ending amount equals your principal value times e raised to the rate times time. Notice there is no n value anymore, because now n is changed to continuously, and if it's continuously, we use base e for our exponential equation. Same exact numbers that we had in that first situation, so now just showing you how this is a little bit different. $1,000 interest rate of 9% for 20 years, but compounded continuously means I put those values into this formula instead. So I would be typing in 1,000e raised to the 0.09 times 20. E raised to the exponent, if you look at your calculators, is on the left-hand column, third button up. You have to hit second natural log, and it'll give you an e to the x. You can also use the e that is above your divide sign and just raise it to the exponent. Totally works the exact same. Again, a little get to know our calculator moment. If we type that in and hit enter, you should get $6,049.65. It should make sense as I'm looking at these that my number is getting bigger as we go because I was compounding my interest more often, and continuously should be your highest one because it never stops compounding your interest. It's not like it waits a week and then compounds again. It's always compounding your interest should be your highest interest rate. And any questions on that?
What should it be?
The formula.
Oh.
From the word continuously. From the word continuously, that's what makes me pick the PERT formula. Okay, shifting gears away from financial situations. Your book represents exponential growth equations and exponential decay equations as a whole new formula. Guys, it's not a new formula. It is the exact same formula we have right here, but n is 1. If it's not financial, n is 1. You're not going to be handed that formula. You're going to be handed this formula, always. The other thing I want to point out is this, and this is huge. If your situation is growing, you put a plus between the 1 and your rate. If the situation is declining, decreasing, decaying, you put a subtraction. And that would go for money as well. If our rate is going down, we are losing money at a rate of 2% a year, we would subtract or have a negative rate in our problem. You can put n in here, but it's a 1. So I would be dividing my rate by 1. I'd be multiplying my time by 1, just like what is up there. And anytime it is not financial, n is automatically 1. So you will not ever be handed this formula again. You will be handed this formula. N is 1 if it's not money.
Is this specifically for exponential growth or decay?
Mm-hmm.
Will it say growth or decay in the problem?
In some way, shape, or form. Getting bigger, going up, decreasing, things like that. Declining, there are other words that mean growth and decay. They may not use those two words specifically, but something indicating whether it's going up or going down. Similarly with our PERT formula, notice this one does not change at all, but again, just to highlight, as we move away from money, we will see things decreasing or decaying more often. So a reminder that your rate in the problem will be positive anytime your situation is getting bigger. It will be negative, a negative number in that PERT formula, anytime that our situation is decreasing. So nothing changed about the PERT formula. Just a reminder that rate is where we change the positive or negative for increasing or decreasing. So if we went back to that situation earlier and we invested $1,000 and we were losing money at 9% a year, our rate would have been negative 0.09 instead of positive 0.09. Okay, so moving on to a couple examples here of non-financial exponential growth or decay. A lot of times it'll talk about population or like growth of bacteria, things like that. a state's population is declining, so that's a key word for us in this one, declining at a rate of 2.6% annually. The state currently has a population of approximately 11 million people. If the population continues to decline at this rate, predict the population of the state in 15 years. It said annually, it did not say continuously. That tells me we're using this formula right here. We are declining, so what does that do to my rate? Negative, right? So if I'm putting that into this formula, my principal amount was 11 million people. Now bear with me, I'm going to put 11. Okay, we're going to talk about that in just a minute here. We start with 1, and then my rate's negative, so minus my rate of 0.026, right? Move that percent to a decimal. Raised to the time, to 15. Okay? I want you to grab your calculators and type that in. And then I want you to look at the answer. And I want you to round that answer to the nearest whole person. You might have to have a discussion about what is the nearest whole person. Okay, now we got to understand what we just typed in our calculator. Okay, so I didn't really pay attention to what I actually typed into my calculator, and I got that. I didn't round anything. That's all the numbers that were on my calculator. Okay, so there's 7 people left in this town. No. This is apparently a bad town because everyone left. We started with 11 million and we're ended with 7 people. No, that's not what's happening right there. What are we looking at right there? 7 million people. But I didn't ask for you to round it to the nearest million people. I asked for the nearest person. Of those numbers up there, does anyone know where I would stop for the nearest person? The 6? Oh, the 6th one down there. I was like, there is no 6 up there. 6th number down. Yes. Think about how many digits a million has, right? If this is 7 million, your comma for million would go here. 100,000, 10,000, 1,000. That's where we would stop for a person, right? And if I were to round that, that would actually be 98 people. We round. Don't ever overthink the rounding. Just round how you guys know how to round. Use the next number to help us. So that's a 5, so I'm going to round this up to 7,409,298 people.
Okay, but they gave us 11, so why can't we just give them 7? They didn't give us like a 7.
Agreed, but my direction said I want the nearest person. So you have a second option of how you could have typed this in your calculator. What else could I have done? Type in 11 million. If I had typed in 11 million, my decimal would have ended up right here. Okay, so if it bothers you or you're not really sure what I just went through to figure out to the nearest person, don't type in 11, type in 11 million. You think so? That's an individual thing. All right, last one. Last one today. State population is declining. This poor state is declining at a rate of 2.6%. Okay, what does that tell us? What does that first word tell us that I have highlighted up there? Second equation, right? Continuously tells me to do PERT. Guys, I want you to do the same thing. I want nearest person. Okay, so based off of those 2 things I just said, you figure out what to put what number in where in that PERT formula, type it in your calculator, and round me to your nearest person. Your rate, yep. Yes, 100%.
Well, the problem with this, I thought you said it was the second. I mean, they're the same.
The only thing that changes is that our rate is negative. And it can be negative in a financial situation too, but typically we're gaining interest, so you don't usually talk about it being negative.
Okay, so these two aren't financial, these two.
Correct. Okay. Oops, I don't have this typed in my calculator.
If I knew how to say numbers, that would be awesome.
7,446,000.
All right. Again, you have the decision to make. Do you want to type in 11 and count out your decimals, or do you want to type in 11 million and round at that decimal point? That is up to you. I typed in 11, which means on my calculator it looks like 7.447625619. And a million, then I know there's a million. 1, 2, 3, 1, 2, 3. It would stop there. The 6 would round that up. So 7,447,626 people. Questions? All right. Your assignment tonight is a worksheet.